Imagine a bonfire burning, not on wood, but on emptiness itself. It does not violate the law of conservation of energy, because this emptiness is dark matter, and this bonfire is gigantic, tens of astronomical units in size, but we cannot see it with our ordinary eyes. According to scientists, such an object could have existed in the early universe. It is a dark star. Now you will learn what Davy Jones's ship and stars have in common, how stars could live forever, and why these invisible giants gave birth to black holes. In 1974, American astrophysicist Frank Wilczek and his colleagues asked a logical and intriguing question. Could there be stars that use something completely different from hydrogen to burn? At the time, it was more of a philosophical thought. But 34 years later, Catherine Fries and her team provided an answer. Yes, it can. In their paper, Stellar Structure of Dark Stars, published in the astrophysical journal Letters, they suggested that the first stars in the universe may not have shone due to thermonuclear fusion, but may have obtained energy from the annihilation of invisible dark matter particles that gather in the center of the star and turn into heat. But to understand how dark stars work, let's first recall how ordinary stars are structured. In essence, an ordinary star is a giant thermonuclear furnace. Its main task is to burn hydrogen. But this is not just combustion. Enormous gravity tries to compress the star into a point. The force of thermonuclear fusion, on the other hand, pushes it outwards. Imagine it as a tug of war. On one side is gravity, which wants to crush everything, and on the other is the force of combustion, which resists. It is this balance that allows the star to shine steadily for billions of years. That's all we need to know for now, because dark stars work very differently. The principle of a dark star is the exact opposite of a normal star. If our sun is a thermonuclear reactor burning hydrogen, then dark stars were powered by dark matter. These invisible particles gathered in the center of the star, where they destroyed each other and released a huge amount of energy. This energy was their fuel. But what is dark matter? Scientists believe that it makes up 27% of the entire universe. We cannot see it because it does not interact with light. It is like a huge, invisible ocean in which galaxies float. But how do we know it exists? There are three main pieces of evidence. First, there is the way galaxies rotate. The stars at their edges move too fast, as if something is pulling them. This only happens if there is invisible mass there. Imagine you are riding a merry-go-round. To avoid falling off, you hold on tight to the handrail. The stars hold on to an invisible handrail made of dark matter. Secondly, there is gravitational lensing. When light from distant galaxies passes by a cluster of dark matter, it bends as if passing through an invisible lens. This proves that there is some mass there that we cannot see. And thirdly, there is the cosmic microwave background, light from the earliest universe. It shows that in order for the first stars and galaxies to appear, they needed an invisible framework to hold them together. And this framework is dark matter. This means that, theoretically, as long as dark matter exists, the fuel for dark stars will not run out. This makes them, if not eternal, then at least incredibly long-lived. But of course, in reality, everything is much more complicated. But what does such an object have in common with Davy Jones's ship? Like the Flying Dutchman, the dark star was invisible, but physically existed. Its energy was completely absorbed inside, without escaping to the outside. It's like a ghost ship that exists. It's huge, it sails the ocean, but you hardly notice it. Speaking of the Flying Dutchman, the myth about it arose because of an optical illusion. Sailors saw what is known as a Fata Morgana mirage. This is when rays of light refract in the air, creating distorted and greatly enlarged images of distant ships. And this ship may appear to be hovering above the water. This is what was mistaken for a cursed ghost ship. But dark stars are not a myth. They could well have been the real ghosts of the early universe, and they were huge. To really understand this scale, imagine this. The largest star we can see is VY Canis Majoris. It is so huge that if it were in the place of the Sun, its surface would engulf Jupiter's orbit. But even it is nothing compared to a dark star. In the most daring theories, they could be dozens of times larger than VY Canis Majoris, drifting quietly at the very center of the galaxy, invisible to all. That is why they could live up to 10 times longer than our Sun. But sooner or later, their fuel ran out, and then a completely different fate awaited them than that of ordinary stars. They did not explode or turn into white dwarfs. Their own gravity, which had been battling their internal energy for billions of years, finally prevailed, and these giant objects, like a cosmic house of cards, collapsed in on themselves. In this way, they could have become the first and largest black holes in the history of the universe, and some of them may still exist today.